Hey, CS50, Solomon Lochi here. This is my final project. I'll give a quick demonstration to kind of show how it works. So the idea is that it's Muhammad Ali dodging, like a punch. Here we go. So how does this thing here work? So I've got an ultrasonic sensor, a servo, and an Arduino from several years ago. Here's my initial sketch here. I've got a disregard that sound. It's a combination of the servo and the sensor there. But the idea is that it would take the distance picked up from the sonar and translate it into an angle on the servo and imitate the idea of someone slipping a punch, for instance. So here's what some of the math I was trying to figure out. Excuse me. Actually, let me go ahead and disconnect the ground here. There we go. Just going to break the circuit. So we've got a minimum angle of 80 degrees, max angle of 120 degrees, and the sonar range, I only want it to look between 2 and 10 inches or 5 to 20 centimeters. Fortunately, Arduino environment has some built-in methods to take care of that. One is called constrain and the other is called map. So Arduino uses its own sort of framework, if you will, that's based on C and C++. And here is my actual code. So as you can see, Muhammad Ali bot version 1.0. Quick description: sketch uses an ultrasonic rangefinder and servo motor to mimic the dodging moves of legendary boxer Muhammad Ali. Here's the circuit. We've got 5 volts going to the rangefinder and the servo, common ground. The rangefinder is connected to pin 4 on the Arduino, and the servo is pin 10, which is a pulse width modulation pin, if you can see that, PWM. And just like week 0 through week 5, we're using C, you know what I mean, or C++, but this is pretty much just C code. So we're including a library called servo.h, which of course maps to the servo that we have right here. Define some constants that I laid out in the initial sketch here. So we've got minimum angle, minimum distance, and the maximum distance. Again, 80 degrees, 120 degrees, 5 centimeters, and 20 centimeters. We've defined that the pin for the servo is set to pin 4. Ping pin, like if you think of, let's say, Counter-Strike or any online gaming, think of ping and pong. I believe it goes back to the actual game of ping pong, and it was used in radar as well. I don't really have anything to back that up, but moving on. We've got 3 methods here, one called setup, one called loop, and one called microseconds to centimeters, which returns a long integer, just a long data type. So this was actually predefined in the example code that I have referenced in my description, directly from the Arduino website. And what it does is it takes the amount of time returned from the sonar sensor, divides that by 29 microseconds, which is the speed of sound, and divides that in 2 because it's the distance traveled. So to work our way up, back to setup, we initialize the serial port. My dog's out there coughing. And we have it set to, I believe this is 9600 bytes per second or bits per second. I really didn't read much in the documentation on this. All I know is it's just a standard for setting up. Initialize the I/O devices. So a couple things for the servo. We've got it attached to pin 10, and we have it default to the minimum angle of 80 degrees. Here we go. I've defined some numbers here that we're going to use later. This block of code from here to about right here, again, was directly from the example code from above via the Arduino website. And what it does is it sends out a few signals from the sonar, and from there it calculates the duration of how long it takes to get that sound, reflect off of an object, and get back to the sonar. From there, we can convert that time into centimeters using the method below, and that will return a figure which we have stored in the variable cm. And yeah, it goes on. So from there, then we map that value to the servo angle. I know I've gone over time here, but that's the short and long of it. I hope this still counts as my final project. Lastly, we delay for 100 milliseconds and then repeat the loop until the circuit is broken or until the power goes out, whichever comes first. So yeah, that is my final project. Here's one more go up. I guess I got to reconnect the ground here, but cool. So that's how it works. Thanks for watching. And yeah, if you need motivation, although it gets really difficult around week 3 through week 5, you can make it through. Check out their Discord and some of the forums on the CS50 website. Ask for help. And it gets much easier once you get to the Python section. All right, best of luck, everyone.